What is up, my lovely little students? Today we're going to be learning about similarity. And specifically, we're looking at triangles and we're talking about some shortcuts to prove that two triangles are similar to each other. All right, all right. And so what does similarity mean? It means that these two triangles, they don't have to be identical, but they're going to be similar, which means let's take a look at this guy over here, Mr. Triangle over here. Hello, Mr. Triangle. We're going to duplicate him. And looking at his friend here, these two triangles are more than similar. They're congruent. They're exactly the same. But that's not what we're learning about today. We're learning about similarity, which means that they are the same exact shape, but maybe two different sizes. So take a look at Mr. Triangle and Mr. Triangle's friend. They are the exact same shape, but they're two different sizes. Think Dr. Evil and Mini-Me from Austin Powers. Think about Despicable Me when he's like, we stole the Eiffel Tower. Well, we stole the little one. Similarity, okay? So they don't have to be the same size, but they do have to be the same shape. It's a little more specific than that, and we'll talk about that in a few minutes, a few seconds, right now. Let's talk about it right now. So there's three shortcuts. The first shortcut with triangles talks about the angles. All right, so let's take a look at Mr. Triangle's angles. He's got three angles, and we all know that with triangles, the angles add up to 180 degrees, right? The triangles' angles have a sum of 180 degrees, all right? All triangles add up to 180 degrees. We know that. So this little shortcut says that if I have two angles in this triangle, and watch what happens when I blow this sucker up. Let's take this Mr. Triangle. Let's shrink him back down to the size he was. And you see how these angles, bloop, bloop, specifically picking out those two, they don't change. So even whenever I make him bigger, when I blow him up, when I dilate that triangle, those two angles stayed the same. And that means the third angle is going to stay the same too, because it had to be a certain number, because the triangle has to add up to 180, all that good stuff. Anyway, so if you have two matching angles, then the triangles are always going to be similar to each other. So that's why it's called the AA postulate. It says if you have two matching angles, A for one angle, A for the other angle, all right? This angle matches this angle. There's an A. This angle matches that angle. There's the other A. So that's why we call it AA similarity. That little squiggly line right there is the symbol for similar. All right. So there's the angle similarity. Boom. All right. Next up, we have SSS similarity. Now, there was an SSS congruence that we learned in geometry, which says if you have one triangle and its three sides match up with another triangle's three sides, then those two triangles are congruent, which means they're exactly the same. And that's true, but this one's a little different because it's not about the sides being congruent or equal. It's about the sides being proportional. So it's going to be a little bit different than the congruence theorem with SSS. All right, because it's SSS similarity. So what we're going to have to do is we're going to have to write I guess you'd call it an extended proportion. We're going to have to find the matching sides. So for SSS similarity, we're going to have to say, hey, this 20 corresponds with that 10. So I'm going to write my first little ratio here of 20 over 10. And then my next pair of matching sides will be the 12 and the 6. So my next ratio is going to be 12 over 6, and it makes the proportion, but we're going to keep that proportion going, and I'm going to match this 14 up with its corresponding part, the 7. So 14 over 7. You see how consistent I was? I always started with this triangle on the top of my ratio, and then I used that triangle for the bottom of the ratio. So And then I just found the matching sides. The 20 matches with the 10. The 12 matches with the 6. The 14 matches with the 7. So that's how you can do that proportion. And now we can check to see if it is going to be SSS similarity. SSS comes from side, side, side. So are the 3 sides of one going to be proportional to the 3 sides of the other? Well, let's see. So you can do this in a couple different ways. You can punch that in your calculator and say 20 divided by 10. Hey, it's 2. Okay. 12 divided by 6. Hey, it's 2. 14 divided by 7, and that's also 2. So if they're all equal, which they are, boop, 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 all equal, then we are happy. And that's how you know if it's going to be SSS similarity. So that's true by SSS similarity. All right, all right. And if it wasn't true, if you had like, I don't know, 2 equals 1.9, then you would say that those two triangles are not similar. But since we had the same number, then they are similar. It doesn't have to be 2. It could be any number as long as it's the same. All right, all right. And the last one is a hybrid, okay? It's a combination of angles and sides. So we're going to have to first see that the two angles match up. There it is. 53 matches up with 53. That's the A part. So you notice how that A is sandwiched between the two S's. So now I've got two sides to check. We see that the A is good, but now we have to check the two sides. So I need you to think, hey, what does that 30 match up with? And you're going to say the 30 matches up with the 10, and you'll be right. And then you go to the next side. On the other side of the sandwich, you're like 18. Okay, 18, who do you match up with? I match up with 6. Okay. 18 matches up with 6. There it is. So again, just like we did with these 2's over here, we've got to check these sides for proportionality. 30 divided by 10. I don't need a calculator for that. It's 3. 18 divided by 6. It's also 3. So winner, winner, chicken dinner. The sides are proportional. The angle matches. So we have our SS, and we had the A to go in the middle. Remember, S stands for the sides. So these guys are proportional, are similar by SAS similarity. All right, so we have 3 shortcuts with triangles. AA, SSS, and SAS. You learned this in geometry. You're relearning it. Let's look at the next example. Example 1, use the triangles on the next page. List the letters of each pair with the similarity shortcut we used. So we've got to decide between AA, SSS, and SAS. Let's do it. All right, so I'm going to write it on this page so I know. I've got to decide between AA, similarity, which means I have 2 pairs of matching angles. So 1, 2 pairs of matching angles. Or maybe it's going to be SSS, where this side, I don't even know what symbol to use. Or they have a matching side, 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 and you'll have to write a proportion for it, okay? And then the last one, SAS, is kind of a hybrid with the 2. SAS. The middle one was SSS. All right. So let's take a look. Where do I start? Lots of triangles on this page. Let's start with triangle C. Let's not start with triangle C. There's not much information with C. I don't know anything about its sides. All I know is one angle. I don't have any theorems over here that are just A. So that's kind of tricky. That doesn't really help me. Let's go look at B. B looks good. B gives me 3 sides to work with. When I see 3 sides like that, I'm thinking it's going to be SSS. So let's find a triangle that also has 3 sides. All right, so let's take a look at triangle I up here. Triangle I has 3 sides as well. So maybe B and I will be similar by side, side, side. So the way I like to do this is I like to find B's smallest side. Hey, 9. All right, and then I like to go up here and find I's smallest side. It's 27. Okay, So I picked their smallest sides. Maybe I'll pick the middle side next. So after 9 would be 13. Over here, the next smallest would be 39. So 13 and 39. It's looking pretty good so far. And then 18 is the biggest side on B. And the biggest side on I is 54. So I was able to pick out the matching sides by going from the smallest side in B to the smallest side in I. The middle side in B matched up with the middle side in I, and then the biggest side of B, 18, matched up with the biggest side of I, 54. Now I could punch this in my calculator, or I could just reduce these fractions. This one's pretty simple. 9 over 27, I could reduce that. I could divide both of those by 9 and get 1/3. 13 over 39, I could reduce both of those by 13 and get 1/3. And 18 divided by 54, I could divide both of those by 18 and get 1/3. So if I just reduce the fractions, you could use a calculator too, and you'll find out that they're all 0.3333333333333. But if I reduce the fractions, I see that those two triangles are similar by SSS, because all three of these are equal, which means the sides are proportional. So B and I, triangle 1, B, triangle 2, I, are similar by side similarity. Cool. Why did I pick that one? Because it had all three sides. Up next. Ooh, look at G. G's got three sides also. Is there any other triangles that have three sides? I don't see one. Oh, yes, I do. I found you, sneaky little F. All right. So if I pick G and F, let's do the same trick. Let's pick the smallest side on G. Hey, it's 12. Let's pick the smallest side on F. Hey, it's 18. Now let's pick the next biggest, 14 and 21. Okay, and then maybe 16 and 24. So I could use my calculator. It's sitting right here next to me, or I could just reduce the fractions. 12 over 18, let's see, 6 goes into both of those, and that's 2/3. 14 over 21, 7 goes into both of those, divide them both by 7. 14 divided by 7 is 2, 21 by 7 is 3. And 16 over 24, divide both of those by 8, and you get 2/3. So after reducing the fraction, I see that the sides are proportional. It's 2-to-3 ratio. So yeah, G and F are similar. And again, we use the side similarity shortcut. Cool. All right, so let's put some X's on some of these, because K looks terrible. K only has an angle. That's it. That's not enough. There's no A theorem. C only has an angle. Get out of here, C. L has two sides. There's no SS theorem. Get out of here. H only has side. There's not a side theorem. All right, so that narrows it down a little bit. In fact, I'm looking at E over here, and I see an angle and an angle. I see a 92. Hey, a 92. I see a 30. Hey, a 30. I got two pairs of matching angles. That's angle similarity. That's E and J. Nice. And then, all right, I see A and D. That's all that's left. A has a 50-degree angle and D has a 50-degree angle. So there's the A part. But let's check the SS part. I've got a 7, and that would match up with that 3.5. How do you know? Because 7 is the smaller number, and 3.5 is the smaller number on its triangle. So 7 over 3.5. All right, let's check the other S. 10 over 5. I could reduce those fractions or divide it. 7 divided by 3.5 is 2. 10 divided by 5 is 2. So we checked it for proportionality, and yes, the sides are proportional. So A is similar to D by side similarity. Woo, that was a lot. We did a good job. Let's see what's next. All right. Similar polygons. We'll save this for later.